record. Okay, so your next assignment is these trig function word problems. And the first ones, it talks about there's a Ferris wheel. So Ferris wheel moves in a circular motion. So anything that moves in a circular motion, you can change into like a wave motion because the person's going to go up in the Ferris wheel, back down. So over time, it turns into this trig graph. They're going to give you the function. So there's nothing to figure out here. It's just to understand what the question is asking for. The function is in minutes, right? So what is the maximum height that this Ferris wheel will reach? Well, that's just asking you what is the maximum of this trig function. Remember, midline, so if you think about it, your midline here is at 50. Your amplitude is 40. So it's going to go up 40 from there and down 40 from the midline. So the top plus would be 90. The bottom would be 10. And then the axle of that Ferris wheel would rotate, around there, whatever it is. So there's a lot of questions they could ask. What's the maximum height that you would go right there at 90? You get on, if it's a negative cosine, remember we're graphing a negative cosine, that would start at the bottom. So where does a person get on? Well, they get on down here at the bottom. And then they start riding. Doesn't matter which way it spins. Over time, you're just going up and down, up and down. The middle of the Ferris wheel, 50. So there's lots of different questions you could answer. So 90, does it say if it's in feet? 90 feet is the height. If it asks you how long does it take that Ferris wheel to go around one time, that would be one period. And again, the period is going to be 2 pi over 1 times the reciprocal of that. So that'd be 5 over 2 pi. Those would reduce. And if it's in minutes, it takes 5 minutes for that Ferris wheel to go around one time. That's a slow Ferris wheel, 5 minutes. But yeah, so there's lots of questions you can ask based on that Ferris wheel problem. And they like those type of problems. So just make sure you're answering the right one. What's the maximum? That's the midline plus the amplitude. Remember, the amplitude is always positive, no matter what the negative is. So the second one, I think it's another Ferris wheel problem. Yeah. So same thing, the height's in feet, the ride's in minutes. This formula is written different than what we're used to. But all they've done is taken the midline, instead of doing plus 50 at the end, they've moved it to the front. It would be the same thing. You can't do that 50 minus 40 and get 10 because that 40 is with this whole expression. So there's your midline. Oh, midline. There's your amplitude, right? So what height does the person start the ride? Well, that's the same question, right? 50 is the midline. If 40 is the amplitude, then it's going to go up to 90 feet as the highest, 10 feet is the lowest. It's a negative cosine. So where do they start the ride? Just like I was saying, at 10 feet at the bottom. If this was a sine function, they'd start the ride on the midline. If it was a positive cosine, they would have started the ride way up here, which doesn't make sense. That'd be a long walk to get up to there just to get on the ride. Questions on those Ferris wheel problems? So might be a lot of words in a word problem, but if they give you the function, just focus on what the function is and what the question's asking for. don't see a word problem and just go to the next one because there's too many words to read. So here we have the function y equals 8 cosine 2 theta. Remember, that's x, just like anything else. That's your variable, 48, right? It's describing the horse on a carousel that goes up and down, so in inches, right? What is the, again, maximum height? So the maximum height is going to be the midline, 48, plus the amplitude. So that's your max. Midline plus amplitude, 56 inches. If it asks you for what's the minimum, it'd be minus the amplitude. Oh, right. If they ask you for what's the period of this one, 2 pi. If that's not a fraction, you can just divide it. You always divide by that number. So it's actually pi. It takes 3.1. Does it say what the time is? Nah. But it doesn't ask for that anyhow. So what's the maximum? 56 inches. My allergies are killing me. Okay, so 2 other ones. So most of them will have that function in there. So just answer the question based on the function. There are 2 types of problems where they want you to write the function. So it says the temperature at a weather station was taken every day of the year. The low temperature was recorded during the first month, and it was 73. So if you think about our graph, that's the minimum is 73. The high temperature during the 6 months, so 6 months later, was 95. Write a cosine function to model this data. Well, if we know the low and the high, we can get the midline, right? It has to be right in the middle. So if you want the middle of 2 numbers, you add them together. Let's change to black. And divide by 2. So 95. So you just find the average of them, right? Add them together, divide by 2. So the middle must be 84. So that's our midline. And the amplitude is what is the difference in either these or these, doesn't matter, but it's 11 either way, right? There's 11 here. You would add 11. So that's your amplitude. So I know that writing a cosine, and it's going to tell you which one to use, would be your amplitude cosine of something plus 84. And in a multiple choice, that might be enough to get you the answer. But now, if we need to, we can do the period. So it starts at the beginning of the year, 6 months later. So it's starting at the low, it's going to the high 6 months later. Now it's back to the low would be 6 months later. So your total period would be 12, right? And so if you want to know what number goes there, it's going to be 2 pi divided by, so that number will always be 2 pi divided by the period, which you reduce, that's pi over 6. You can put an x here, theta here, it doesn't matter. But if the period is 12 months, and I know that because it's going for a full year and they're talking about months. The only thing, if I'm going to start, if it starts at the low, we're going to make this a negative. So if you know the maximum and the minimum, you can get the midline, just find the average, and then the amplitude is the difference from the midline to the maximum or minimum. Right, so one more. This time the temperatures go from -6 to 60. The highest temperature is in July, the lowest temperature is in January. Write a cosine function that models the temperatures above and below since July. So since the high temperature, right? So the high is 60, the low is -6. So your midline, add them and divide by 2. So that's 54. 60 plus -6 is 54, divided by 2, so 27. And so our amplitude, 60 minus the 27, is 33. So you're writing a cosine. Starting in July, it's starting here at the high temperature, so you want a positive cosine plus the midline. If the midline was a negative number, you just write minus. And now this is that every 12 months again. So remember to get the number that goes in here, it's 2 pi divided by the period. So just be again pi over 6x. And you could do f of x instead of y, whichever one you like. Does not matter. Okay, so questions, comments, concerns?
No, sir.
Okay.